Distance formula. Okay. So the distance formula fits into the Pythagorean theorem, again, because it's derived from the Pythagorean theorem. It's going to look different to you, but we're going to talk about how it really is the same. Okay? So if we're going to define the distance formula, we say the distance formula is derived. What does derived mean? What do you think derived means, Brad?
It's kind of like from something.
Yeah, it's created from it, right? It started out and we did some manipulation and we ended up with something different. But it's came from that. So the Pythagorean theorem is what it's derived from. The distance formula is derived from the Pythagorean theorem and is used when a right triangle is on a coordinate plane. All right, so again, we're working with distance formula, so we're figuring out the distance, right? Distance formula tells us how long something is or how far it is between two things, the distance. So we're going to have a graph. We're going to have these ordered pairs, an XY combination. For example, if point A is 2, 3, and point B is -4, -1, we're going to ask, what is the distance between points A and B? All right, so you have a graph. Just handed them out. Some of you people are crazy, and you can't live with the fact that your graph is not perfectly cut out. I hope you get over it at some point in time in your life. But if you can fix it, there's your desk. And you're going to glue this graph close to the end of the page, right? You're going to glue this graph on your paper right here. There are also glue sticks in the tubs on your desk. If you are cutting out your graph to make it more beautiful, it may not be on your desk yet, but the back rows have trash baskets, green trash baskets. Put your trash in there. When your table is done with it, pass it to the table in front of you. I suggest it doesn't really matter because you can be okay and figure it out. But when you're gluing it, you know, there is a right way to glue it on your paper. so that the numbers actually go the correct way. Y-axis should be at the top because it's your vertical axis. X-axis should be horizontal because it's your horizontal axis. If you glue it sideways or upside down, don't panic. You're a smart individual. Just ignore the numbers and actually do some counting. It'll be okay. We will survive. So there are two ways to solve this problem that you've been given. Of point A and point B and finding the distance between them. There are two ways to solve this problem. The first way to solve this problem is by using the Pythagorean theorem, what we've been learning about. Right? So method number one is the Pythagorean theorem. We can use the Pythagorean theorem to solve this problem. That's the first method. It's a little bit more work, which tends to scare everybody away, right? But there's a time and a place. So to do the Pythagorean theorem, you're going to step number one, plot the points. So in order to use the Pythagorean theorem, you must have a graph. So if you're not provided a graph, you're going to have to draw a graph. Okay? So if I plot my points, I've got 2, 3, which is right here, point A. And -4, -1, point B. Plot the points. Let's add connect. If you have to have a straight edge, use a piece of notebook paper, the side of your MacBook, a calculator, something. Connect the dots. Or just go slowly, and it works out most of the time. But here's my problem. Like, can I count, like, oh, here's 1, and here's 2, 3, 4, 5, 6. Can I count like that? Because they don't, it's diagonal, right? It's not this long, which is 1 long. It's diagonal. So I can't count it. It's going to be a decimal. So after you plot the points and connect, you're going to draw the legs. And I'm going to do this in a different color just so you can see the difference on mine. But look, I'm going to draw the legs to make it a right triangle. Now again, one of our goals this year is to attend to precision. So don't be like, boop, boop. Is that a right triangle? No. It needs to be a right triangle. So you need to follow the axis vertically and horizontally. Like you need to follow the track. Be very deliberate. Step 3, count the leg lengths. So step 1 was to plot the points and connect them. Because the points, the distance we're looking for is called the what? Is the what of the triangle? Hypotenuse. hypotenuse? The diagonal. We're finding the hypotenuse. So we plot those points and we're given the hypotenuse. So we have to fill in the legs to make it a right triangle. Now I can count the legs because are these things that I can count?
Yes.
1, 2, 3, 4. I can count that because they're perfectly on the grid lines. And this one is 1, 2, 3, 4, 5, 6. What do you think step 4 is going to be?
Use the Pythagorean theorem.
Use the Pythagorean theorem, and what are we solving for?
Hypotenuse.
Hypotenuse. I'm going to do it right here up above just so that I save a little bit of space. I'll substitute and show you every step. Has anyone started doing some shortcuts when doing the Pythagorean theorem? Like not writing down a squared plus b squared equals c squared and then underneath it writing 6 squared plus 4 squared equals c squared. Did I substitute correctly? Can you substitute any other way? What can you do, Gage? I can switch the 4 and the 6. Commutative property of addition tells me that that doesn't matter. 36 plus 16 equals c squared. I mean, you could skip that step. Lots of people are getting to that point. They've done this enough that they're skipping the monotonous part of writing everything down. What is 36 plus 16? 52. So 52 is my answer?
No, you got a square root.
Square root, because I don't want c squared, I want just c, correct? So c equals, give me hundredths. 7.21. Oh, I'm going to bloop, bloop. So that's method 1. What do you have to have in order to do method 1? What would make this infinitely harder if I didn't give it to you to cut out and glue on your paper? A graph. Pythagorean theorem, it's probably faster to do if you have a graph. If there's already a graph and a picture provided, use the Pythagorean theorem. But I'm not going to give you a graph for this next one. You're welcome. Let's say if A is 7, negative 2, and B is negative 6, 1. No, let's make that negative 1. But I'm not going to give you a graph. If you only knew the Pythagorean theorem method, you would be drawing your own graph right now, but you'd have to be attending to precision and making sure that it didn't look too wonky. You'd be plotting the points, you'd be drawing this, that, and the other. It's a lot of work. Could you do it? Yes. Or you can do the distance formula. Now here's what you need to know about the distance formula. These types of problems, when you're finding the distance between 2 points, is always going to be a diagonal line. It could be a horizontal line or a vertical line, but 99.9% of the time it's always going to be a diagonal line. So what are you always finding? What part of the triangle are you always finding? You're always finding the hypotenuse. Disclaimer, like most of the time. Every time tonight on your homework, you're finding the hypotenuse. So you're finding the hypotenuse. That's the way these problems work. Because if you were finding a leg, like you just count and it'd be over, right? But you can't count because these are diagonal and the diagonal doesn't go through grid marks, and so you can't count it. So you're always finding the hypotenuse. So let's talk this through. If you were going to tell me, like a quick, easy method to find the hypotenuse using the Pythagorean theorem, like, explain to me what you would do. Like, I don't want, like, substitute this, blah, blah, blah. I just want to know, like, a short, dirty method. Like, Mrs. Long, here's a fast way to do it. You count the leg, square it, and you count the other leg and square it. Is that true? Right? The sum of the squares of the legs? All right, so let's talk this through. If I had 7, so if I thought over 7, down 2, and -6, -1. If I wanted to know the legs, I'd have to find the distance down here, correct? Horizontally. What axis is horizontally?
X.
X. So I have to find the distance between the x's. So from 7 to -6, I want to know how far apart they are. Is that true? And then I'd have to find the distance between the y's, correct? So I'd want to know the distance between -2 and -1. Is that true? How can you find the distance between 7 and -6? What does between mean in math? Like, if I asked you how many numbers are between 6 and -7, how would you figure that out? What operation would you do? You'd subtract. So, the formula is x1 minus x2. Because we're subtracting the x values to find how far apart they are. Right? And those numbers are sub-numbers. They're below, they're down on the bottom. They're not squared numbers. Those are exponents up top. These are sub-numbers. They just tell me, take the x value from the first one minus the x value from the second one. And that tells me my base. It tells me the bottom leg. And I'm going to square it, because I have to take the base, the leg, the distance of the bottom, and square it. So to find the distance of the bottom, I take x1 minus x2, and that gives me the distance, and I square it. Plus, how do you figure out how tall the triangle is? The height of a triangle. The height is on the x or the y axis. The y-axis. So what's the distance between the y values? I'm going to take y1 minus y2. And I'm going to square it. I'm finding the distance of the base, which is x minus x. And I'm adding the distance of the height, which is y minus y. So I'm taking my leg, x minus x, squared, plus my other leg, y minus y, squared. But what do I have to do to every Pythagorean theorem problem? At the end, square root. So I'm going to put all of this under a square root. And that's the distance formula. to find the distance between two ordered pairs, it's the Pythagorean theorem. It's leg squared plus leg squared, and then take the square root. It just doesn't look like leg squared plus leg squared because they're ordered pairs instead of numbers. But if I substitute my values into that problem, I will get numbers. Let's try it. What's the x from the first ordered pair? 7. Minus, what's the x from the second ordered pair? -6. Boop, boop, right? Negative, negative makes a positive. Squared. This delay is killing me. Plus, what's the y from the first one? -2 minus, what's the y from the second one? And again, remember, our formula, again, that changes. Our formula has to be minus. It may change to addition once we substitute, but the formula is minus because we're finding the distance between two ordered pairs, and the word between in math means subtract. And the whole thing gets square rooted. So I substituted, check. I'm simplifying. I'm going to write out every single stinking step just so that if you get confused and go back to your notes, it's all there, right? So what's 7 plus 6? 13 squared plus, what's -1 or -2 plus 1? -1 squared. What's 13 squared? $169 plus what's -1 squared? 1. Ladies and gentlemen, remember this from last year? I know I do. -1 in parentheses squared is different than -1 squared without parentheses. Because this problem means -1 times -1, which results in a positive. This one means -1 times 1 because the 2 only touches the 1. The 2 up here touches the parentheses, meaning the parentheses repeat. But this one means only the 1 repeats with a negative out front. So it's really important to remember those parentheses because they're in our problem. -1 times -1 is +1. $69 plus 1 is, or 169 plus 1 is 170. Am I done? You have to square root it. I guess I'll go back and add those square roots that I forgot to write, huh? Give me nearest thousandth. Thousandth. It's going to be 13. How do I know it's going to be 13? Because 169, the square root of 169 is 13. This is 170, so it's a little bit bigger than 13. 13 point what? Zoe? Or not Zoe. Sam?
13.04.
Give me one more. 3 decimal places.
13.038.
038. Perfect. So this method is used when you do not have a graph, you just have ordered pairs listed. If you subtract the x values, get an answer. Subtract the y values, get an answer. Subtraction is key. Then square both those numbers because it's the sum plus of the squares, exponent, of the legs equals the square of the hypotenuse. Down here, the square of the hypotenuse, 170, we square root it to figure out what the hypotenuse is. Again, find the distance, subtract the x's, leg number 1, subtract the y's, leg number 2, then you square them and add them together. The sum of the squares of the legs equals the square of the hypotenuse, and square root it. What if I did 7 minus -6, but someone else did -6 minus 7? My first ordered pair, I chose to always do the top minus the bottom, but somebody else lives a different life, marches to the beat of their own drum. They do the bottom minus the top everything. Are we going to get the same answer? Test it out. You can write it on your desk. See if it works. Try it out. Does it work if you, instead of doing point A minus point B, what if you did point B minus point A? Is it the same? Is it the same? Is it the same if you do point B minus point A? So, who can tell me what x1 minus x2 would be if you started bottom to top? Instead of 7 minus -6, what would you have? -6 minus what? 7. Yes? What would the y look like? If we did -6 minus 7, what's your y going to look like? -1 minus -2, correct? What's -6 minus 7? -13 plus. What's -1 plus 2? 1. What's -13 squared? -13 times -13 is 169. Plus, what's 1 squared? 1. What's 169 plus 1? What's the square root of 170? Is it the same? It does not matter which one you pick to be your first ordered pair. It's going to work out. If you're like, I don't know which one's the first ordered pair, my rule of thumb is the first one written is the first ordered pair. If you can't work that way because you don't like to follow directions and rules and the way things logically make sense, that's okay. Pick whichever one you want to do first. I don't care. But if you pick the top one to be x1, the top one has to be your y1. You can't switch halfway through. If you start with the first one for x's, you start with the first one for y's. If you switch it up on the next one and you're like, throw caution to the wind, and you do y, the second one, you got to do x, the second one. It's got to be consistent.